Thank you. All right. I apologize once again for being late. And so my name is Rajat, and I have been working as an Informix DBA for 11 years now. And of those 11 years, I've been working with Walmart for 4 years. And today I'm going to present this session about how we can implement observability or dashboards using Prometheus and Grafana to monitor our Informix databases. And so let me start with the importance of observability. Observability, it helps us to give an insight into our database systems or any system that we implemented, and it helps us to see the patterns or outliers and then take actions accordingly. And this concept was introduced by a Hungarian American engineer named Rudolf E. Kalman. And with this observability implemented, we can identify the outliers and identify the patterns, and then which can help us to take actions on those outliers, and which will in turn help in increasing the availability of our systems. So as we know that the observability is one of the abilities that has been being given importance across the entire IT world. And so once if it helps in increasing the availability of the system, that in turn increases the stability of the systems, which would imply our customers to be having more trust in us, and and in turn it will drive the revenues higher, because if your database is up more of the time, then your revenue is higher. Okay. So let me begin with the story of World War II. So during the Second World War, when the warplanes, Allies warplanes used to come back from the battles, there was a team which used to check, where the warplanes were hit by bullets, to reinforce those parts of the plane, and so that those planes could be made stronger, and a better defense could be placed. So initially, when those analysts looked at the planes, they put reinforcements on the parts of the plane which had more bullets, but that did not help them. But then there was another analyst or mathematician named Abraham Wald. He told that the armor doesn't go where the bullet holes are. It goes where the bullet holes are not there. That is on the engines. So he explained the concept that whenever these warplanes are being hit on the engines, then that is when they're going down and they don't return back. And that is why we do not see the warplanes with bullet holes on the engines. So he told that the armor should go on those areas where the bullet holes are not there. So implementing observability is as important as driving analysis from that systems. Okay, so the traditional observability system was, especially in Informix world, was to have a bash script to collect data on database servers running at a set frequency, and then these scripts would send back data to a centralized database, and from those database, we on the centralized server again we would have shell scripts that would query that database, and then send out email alerts and pagers and whatnot. And there were multiple email alerts for multiple emails for multiple alerts, which were resulted in hundreds or probably thousands of emails, which were prone to be missed due to human factor, because when you have hundreds of emails, there's a huge chance that you will be one or two might get missed, and then it will result in a downtime or an outage. And the other downside of this email based alerting was that you cannot visualize the trends or patterns in your system usage. And of course, with no such data retention, it was difficult to predict or implement, bring in some kind of machine learning or artificial intelligence to your patterns, or predict, based on your previous patterns, predict what will be the usage in upcoming future. So the current options for Informix monitoring. So we did a POC on Informix HQ that has been provided as a native monitoring solution, I think, with the Informix 14.1. And it is a brilliant tool with customizable sensors, and within the tool, within Informix HQ itself, once it is configured and set up, we can run administrative commands as well, like onstat and SQLs. And there are various options and knobs that Informix HQ provides, which we can configure to make it only read-only dashboard, so that we can provide those dashboards for application teams or other customers, so that they can check out those dashboards and take actions according to what they see on those dashboards. So why this solution using Telegraf, PromQL, and Grafana when we have Informix HQ? So in our organization, basically, we wanted to maintain a homogeneity across the multiple database products, the solution that we have been using. And besides that, it provides us the retention period, which is scalable. We can hold a lot of data, based on our time series database capability, which could be, ranging from days to weeks to months. And once we have the data in the time series database, we can plot the data from the database to Grafana or any other dashboard using PromQL, Prometheus query language. And what we found is that this Prometheus query language is extremely flexible, and you can slice and dice the data in any way you want with this PromQLs. So I'll cover a few functions which PromQL provides in upcoming slides. And there is a scope of implementing, machine learning and on the past data and patterns, and maybe we can predict the future data from the past data. And PromQL also has some function ready-made functions which can be used out of the box to implement this machine learning. So basically, the observability stack, it comprises of 3 items: the target system that we are monitoring, and the time series database, wherein we store all our metrics, and the third would be a graphing tool, which takes the data from time series database and plots on the graphing tool with the help of PromQL. There are multiple products available for pulling the metrics or sending the metrics. Prometheus being one, Telegraf being the other one. And similarly for time series database, there are a lot of open source products that are available in the market, InfluxDB and M3DB and whatnot. And the same case is for graphing tool. There are various products available, that is Grafana and Graph, and there are a host of other tools as well. So in our solution, what we are using is the Telegraf plus the M3DB and the Grafana. Okay, so this is a basic structure, architecture which I have pulled from the Prometheus website. And so there are jobs or exporters running, which would expose the metrics on a port, and then based on your product, you could either pull the metrics from the target database server, or you can push the metrics. So in Telegraf, basically what it does is it pushes the metrics, and if you use the Prometheus client, it will pull the metrics, and then you send it to a time series database, that is the Prometheus server, or maybe another database like M3DB or something else, depending on your use case. And then from this time series database, you can use the Prometheus query language to plot the data on a dashboard like Grafana or Prometheus dashboard or chronograph. And also you can set up alerts, which will send out alerts on email alerts or PagerDuty or X Matters or any other alerting tool. Okay, so coming to the technical side, on the Telegraf configuration. So what we did is, what we need to do is, first we have to install the Telegraf package on the database server that you want to monitor, and then configure that Telegraf to run as a service, so that whenever there is a reboot of the service will come up on its own, and there will be no loss of data. And then we need to write a customized shell script to get the Informix metrics. So the Telegraf has metrics like CPU, memory, and system metrics, disk IO, etc. Already are available out of the box. But to get the Informix metrics, we had to write a custom script, which was in Bash script, and then provide appropriate permissions and ownership to this script, and then configure the telegraf.conf file to put in your requirements, as in the frequency of your running to push the metrics, and your custom script, and the CPU, memory, etc. What intervals you want to send those data. And then the final step would be to start this agent. Once started this agent, then it will take the telegraf.conf file as an input, and based on the configuration, it will start to send the metrics to your time series database. Okay, so this is how the Telegraf configuration file it looks like. So in the first section, if you see, there is it's called as agent, and there is an interval which is the default interval. So if you set it to 60 seconds and you do not override for your other sections, then for each of your metric type, metric group, it will send the data at 60 seconds. And then there are other configurations that can be tuned. For example, the batch size and the buffer limit, you can tune based on your capacity. The flush interval is, it is kind of a timeout. So if within 60 seconds your database server couldn't process your data, the metrics, then it will time out, and it will wait for the next batch to run. And then there are other options which can be configured as per your use case. And the second part is the input plugins. This is the more important part, which I would like to talk more, is that, so if you see the inputs.cpu, this is what I told, that the system related metrics, CPU, system memory, and network processes, swap, etc. are available out of the box, and you can configure it as per the configuration here. If you see, the field drop is equal to time underscore star, what it does is, whatever metrics name starts with time underscore, it will not send those metrics, and it will send the other metrics. So the last part is important here, inputs.exec. So this is where we configure the path of our bash script that we write to generate the Informix metrics. So whatever path you have placed your bash script, you need to give that path here, so that Telegraf will pick up, go to that path, run that script, generate the metrics, and convert it into Telegraf format, and then it will send it to the time series database. And then again here, if you configure your interval, it will override your default settings. So for example, if I have set interval is equal to 60 minutes here, so what it will do is, for the remaining metrics like CPU, system, memory, net, process, swap, it will send out data at every 60 seconds. But for the Informix metrics, it will send it out at every 60 minutes. And the timeout here is 60 seconds. So if your script doesn't execute within 60 seconds, then it will time out and data will not be sent. So this all needs to be tuned based on your capacity and your use case. So the custom script, what it does is it will query the Informix system tables to generate the KPIs. So the output format of this script, this custom script should be, it should look like a metric group name, comma, and then, the label name is equal to the value, and then, whatever how KPIs, and then there should be a space, and then, the KPI name is equal to and the KPI value. For example, here I have shown it. So system profile is the metric group name, and then you have the different KPIs. Discrete is equal to so and so, buffer rates is equal to so and so, and the other values, other KPIs. And then for say, for example, for a particular table, you need to generate these metrics. Then the output should look like table underscore KPI, and then database is equal to the database name, and table is equal to table name, and then the buffer reads, disk reads, lock requests, sequential scans. So due to confidentiality, I cannot share I could not put the exact data on these slides, but this is how the output format of the custom script should look like. And once once that script is configured in your Telegraf configuration file, and the Telegraf runs and executes that script, then it will generate, it will convert that Telegraf, that script output to Telegraf format, which will look like here, the metric group name, and then the label names for your KPI, for example, your server name and your database name, and etc. And then space, and then your KPI, different KPIs that you have. And then what Telegraf will do is it will add a timestamp to that output, so that when this data goes into the time series database, it will have the timestamp of the metric and the different label, metric group name, and the label and the values. For example, I've shown here. The system profile is the metric group name, and then your disk reads on the server, buffer reads, disk writes, buffer writes, etc. And then finally the value, the last value is the timestamp. Okay, and similar is in the second example, table KPI, and the database, what is the database name and the table name, and for that table, what is the buffer reads, the disk reads, the lock request, sequential scans, and then the timestamp. So at this timestamp, what was the buffer reads, disk reads, lock request, sequential scans, etc. for this particular database and this particular table, and there will also be a server name associated, which then goes to the time series database, and then with the help of PromQL, this data can be pulled and plotted on the Grafana dashboard. Okay, so this setup can be rolled out to multiple servers, hundreds and thousands of servers, and then what it will do is it will send from each of these servers, the Telegraf will send the data to the centralized time series database, which could be any of InfluxDB or Prometheus or M3DB. And then from this time series database, we can use the PromQL to read the data, Prometheus query language, and plot the output on a Grafana dashboard, or Prometheus dashboard, or a chronograph dashboard. But Grafana seems to be the most popular choice. Okay, so this is how the dashboard kind of looks like. This is for a particular server. You can use the Prometheus query language in the background, which pulls the data from the time series database, and then it plots beautiful looking graph, which tells us these are the tables with the highest buffer read. So when we hover over one of these towers, it gives the details of the database name and the table name. And then in the dashboard itself, on the top of the dashboard, there is a drop down wherein you can select your server name. And for each of the server name, the graphs will change. And for that server, you will get to know which tables have the highest buffer reads, which tables have the highest lock requests, highest sequential scans. So this is what is extremely customizable depending on your bash script, what KPIs you want to put on the graph. And then in the last part, you can put something like number of user threads. So this part has been particularly useful with the number of user threads. And once the data is in time series, your time series database, you can even create a dashboard which can give you an overview of your, say, for example, you rolled out this setup to 1,000 servers. It can give you an overview of all the 1,000 servers. For example, you can use Prometheus query language to pull, to plot a graph of the top 20 servers in terms of the number of connections. So, for example, the normal number of connections is say 2,000 on a server, and suddenly you are monitoring, and suddenly you see that the number of connections has gone to 5,000. Then you can go and investigate what happened and from where those connections are coming, and work with the application team, or before before it becomes an outage, with the help of these dashboards, it can be prevented, and proactive action can be taken. So these are the few PromQL functions that are available. Some of your metrics, the rate of change, and then the delta between metrics, and you can even do an average over time, sort, and top n metrics, and then you can even plot histogram quantile. So what I mean to say is that this is extremely flexible. Once you have the data in your time series database, then there are a lot of functions that can be used to create a lot of graphs, which are really helpful. So that is it from my side, and I apologize once again for being late. I was on the other meeting, as I thought it is a sequential presentation. The three presentations are supposed to be sequential. That is what I thought. I apologize again for being late.
Do we have any questions in the chat? I haven't seen any. Okay, thank you for the presentations. Hope you all have been enjoying this session so far, and we look forward to seeing you all at the next sessions. Have a nice day.
Thanks, everyone, and have a nice day.